So, good day. I am Mark Darius Maborang and my partner is Harvey Barajas. So, this is our report for activity 4. So, first, here we define an array vertices containing both vertex coordinates and color. And an array indicates specifying the order of vertices for drawing triangles. And then here we initialize GLFW for window and context creation. Then after that, we set the OpenGL version to 3.3 and uses the core profile. And then we create a window with dimension 800 times 800 pixel and a title activity 4. And then we check for window creation error. And then we set the created window as the current OpenGL context. Then after that, we load gland to initiate OpenGL function pointers. And then we set the view perk size to cover the entire window. And then we create a shader objects using vertex shader. And then and fragment shader. Then we generate a vertex array object or the VAO and bind it. And then after that, we create a vertex buffer object or the VBO and element buffer object, also known as EBO, and then linking them to the vertex and index data. Then we link VBO attributes, coordinates, and color to the VAO. Then we unbind VAO and EBO to prevent accidental modification. Then we retrieve the uniform ID for a uniform variable name scale from the shader program. Then here we specify the background color and clear the back buffer. Then activate the shader program, assign a value of to a scale, uniform, bind the VAO for rendering and draw primary tape using indice. And then here code is we delete the VAO, EBO, and VBO and shader program objects. Then we destroy the GLFW window and terminates GLFW. And here the hashtag version 330 core. This line specific specifies the GLSL version to use. The core profile indicate the use of modern OpenGL features. Then after that, the line local equal 0 in a vec3 apos we specifying that the input variable apos is a 3D vector representing the position of vertex. It is a band of attribute location 0. Layout location is equal to 1 in a vector color. That's specify that the input variable a color is a 3D vector representing the color of a vertex. It is a bound of attribute local 1. And then the out vec3 color is declares an output variable color of a type vec3. This variable will be passed to the fragment shader. And the code, and then this code block uniform float scale declare a uniform variable name scale. Uniform are constant across a rendering call and can be set from the application. Then this the void main that the entry point of the vertex shader. And then this code GL position is equal to vec 4 open parenthesis, apox.x plus apox.x times scale, and apox.y plus apox.y times asterisk scale, and apox.z plus apox.z asterisk scale, and 1.0 semicolon. That calculate the final position of the vertex in homogeneous coordinates. The vertex position is modified based on the scale uniform, effectively scaling the object. The vector constructor creates a 4D vector, where the first three components are the modified position and the last component is 1.0, indicating a point in homogeneous coordination. Then this code block, the color is equal to a color, semicolon. This passes the color attribute to the fragment shader. The color attribute received from the vertex shader will be interpolated across the primitive and used in the fragment shader for further processing. In summary, this vertex shader tags vertex position and color as input attributes, scales the vertex position based on a uniform scale, and passes the modified position and color to the fragment shader for further processing. And then next, this code block, which is the hashtag version 330 core, this is specified the GLSL version to be used. The core profile indicate the use of modern OpenGL features. And then this out vec for frag color semicolon, this declare an output variable frag color of type vec4. This variable represent the final color of the fragment pixels. Then this in vec3 color semicolon, this declare an output variable for this declare an input variable color of type vec3. This variable is received from the vertex shader and represent the color interpolated across the primitive. Then this void main, the entry point of the fragment shader. And then this code block, which is the frag color, is equal to vec4 color 1.0f semicolon. This assign the final color to frag color. The vec4 constructor creates a 4D vector using the color as the RGB component and 1.0f as our alpha transparency component. This line effectively set the fragment color to the interpolated color received from the vertex shader with the full opacity. In summary, this fragment shader takes an interpolated color from the vertex shader and assign it as the final color of the fragment. The resulting frag color is 4D vector representing the RGBA component of the fragment color with full opacity. And then next, this code block, which is the hashtag ifndef VAO class H and hashtag define VAO class H. So these are include guard to prevent multiple inclusion of the header file. And then this hashtag include this library. This library include the GLAD library, which handle the loading of OpenGL function. And then this library, which is the include vbo.h, this include the header file for the vertex buffer object, which is the VBO. And then Here the class VAO, it declare a C++ class named VAO. Then this public specify the access level for the class member, indicating the following member are accessible from outside the class. Then this code, which is the GLUINT ID semicolon, this unsigned integer that represent the ID refers for the vertex array object in OpenGL.